Alright, we're going to go over proof positive. Go ahead and make sure you complete this warm-up here. Okay, know what kind of angles these are to be able to solve that. Alright, so we're going to go ahead and make conjectures about certain things that we've learned about in the previous lessons. And so we're going to take a look at this diagram here. And they're asking us to consider that AB and CD intersect at point E. So these two lines are intersecting, making a cross. You're going to go ahead and answer these questions here using this diagram that was given to you. Now, once you've answered your questions that were given, basically they're telling you here that the reason that they were asking all those questions is to send you in circles, for the simple fact that in math, that's why we come up with things that are called postulates, statements, and even theorems, which we'll go into. And so for the angle addition postulate, I'm going to go ahead and draw some examples for you, and I need you to draw them on your paper for your notes, please. So for the first one, we have angle addition postulate. So I'm going to go ahead and draw an angle here. And then we have angle A, B, and C, okay? And then they're telling you that the point D lies in the interior of that angle, which means that if you had an extra angle going here, this is your last point that you have here. What they're telling you is that if point D lies in the interior angle of ABC, so it's inside this whole angle, they're saying that ABD, so ABD plus DBC, so plus DBC, will actually give you the whole measurement of ABC. So that's what they're saying here. For the next one, they're talking about linear pair postulate. So they're saying that two angles form a linear pair when the angles are supplementary. So we've known this one. So here you have two angles. So we have this angle and then this angle, that when you add them together, they're going to equal 180 degrees. So I'm going to keep coming out bad. I'm putting two arcs because these are not congruent angles, as we can see. And as we know, supplementary angles add up to 180. And now the segment addition postulate, they're saying if point B is on AC, so we're going to write this one down here. So we have if point B is on AC and between points AC, so we're going to put AC, it says then AB plus BC is equal to all of AC. Or you can talk about the measurement of line segment AB plus BC is equal to the whole thing. That's what they're saying here. So you're going to go ahead and go through these properties and the statements, and you're going to create some of the examples here that are being asked. So for number one, they're asking you to give an example for each of these. An addition property of equality. So that's telling you that if A, B, and C are real numbers, then if A equals B, then you would have A plus C is equal to BC. They want you to do this using numbers and variables. So for example, if we start off with A equals 5, right? And then we're going to say that then if A plus 2 should be the same thing as 5 plus 2, because we said that A equals 5. I'm going to do one more example with you, and then you guys are going to do the other ones. Reflexive property is telling you that if A is a real number, then A has to equal A. For instance, 6 is a real number, 6 is equal to 6. That is reflexive property. It's equal to itself. You guys are going to do the rest of these examples. Now, before you move on to the next section, you really need to make sure you're understanding this example here. They're telling you that the angle measurement, so if you have angle 1 is equal to angle 3, we should know that these two are congruent. Then they're saying that then if angle 1 plus 2 should equal the same thing as angle 3 plus 2. Right here we have the segment measures, and they're saying the same thing. So if AB is equal to CD, then AB plus BC should be the same thing as BC plus CD. Remember, we said these two pieces were congruent. And then our distances here, we have if AB is equal to CD, so if this is equal to this, then AB plus BC should equal BC plus CD. So from this piece should equal this piece. So they're just basically basing it off of distance. So for this one, we're going to go ahead and consider each diagram and write a statement that applies for the property of angle measures that we were given. So for this one, we're going to do the subtraction property of equality. So we want to go ahead and subtract these angles so that we can make a statement. So for example, if we're having AEC, so this angle here, and then they're telling you that that angle should equal the same as angle BED. So they're saying those two angles are equal to each other. Then that means that if you have AEC and you subtract this piece here, BEC, so if we take away this piece right here from AEC, they're telling us that that should equal the same if you were to take BED and subtract this piece, BEC. So the way to think about it is, if I said that this was 30 degrees, and then I said from here it was also 30 degrees, and let's say that this was 10, if I took angle AEC that is supposedly 30 degrees and I took off BEC that is 10 degrees, that leaves me with 20. Then if I took BED and I subtracted, again, the 10 degrees, I'm going to be left with 20 as well. So they're saying when you do that, you're going to end up with this angle AEB. So AEB should be the exact same thing, the measurement of CED, because remember, we subtract this piece from both of them. So that's a subtraction property of equality. Now reflexive property, reflexive means that it's equal to itself. So if I'm looking at angle A, then the measurement of angle A should equal the measurement of angle A. That's me giving a statement based on angles. You're going to go ahead and do C and D on your own. Once you're done, we're going to go ahead and look at number 3 and consider the diagram. And now you're going to do the same thing, but instead of angles, we're going to talk about segment measurements. And I'm actually going to do the last two instead. So looking at C, substitution property, that means that you're substituting something that is equal in place of something else that's equal. So if I'm looking at CD here, I'm saying if CD is equal to 8 inches and EF is also equal to 8 inches, that means that they can both replace each other because they both equal the same thing. So my substitution property would be if CD equals 8 inches and EF equals 8 inches, then that means that the measurement of segment CD is equal to the measurement of segment EF. That's a substitution property statement using segments. Transitive property, that's the one where if A equals B and B equals C, therefore C equals A as well. So it's like a cycle, right? So if this is equal to this right here, and then this is equal to this as well, that means that this is going to equal the original one because it's a cycle. So if I were to say that MN is equal to WX, the measurement, and WX is equal to RT, then I can say, therefore, the measurement of RT is also equal to MN, which was the one that you started off with. So you guys will finish the other two AB. Make sure that you finish up to this page.